Hello everyone and welcome back. Within the topic of fluids, Torricelli has a couple of claims to fame, and this video looks at one of them. So Evangelista Torricelli lived in the early 1600s. He was a student of Galileo's, and one of his claims to fame was that he was the first person to construct a barometer. A barometer is an instrument that can be used to measure pressure. He was also able to explain how and why water could be stored in a tall reservoir. In this image, we see Torricelli constructing his barometer. So he has down here at the bottom a container of, let's say, fluid, and now he's got holding a tall glass tube. So this tall glass tube is closed at the top and it's open at the bottom. And he must have used a vacuum pump or something like that to suck all of the air out of this tube so that now it's a vacuum tube. So he's holding the bottom so that no air can get into the tube, and he's getting ready to lower this tube into the container of fluid. I think we can best understand Torricelli's barometer by looking at this example problem. So it says a vacuum tube is placed upside down in an open container of mercury. How high will the mercury rise in the tube? So this is the container that was in the previous picture, and Torricelli filled this container with mercury back in the day. So we know that there is air pressure pushing down on this open container, and the air pressure is 101,325. So because there's nothing in this vacuum tube here, the air pressure pushing down is going to force mercury up into this tube. And we can calculate how high the mercury is going to go up into that tube by P equals rho GH. So we have air pressure pushing down equals rho is the density of the fluid, so that's the density of mercury in kilograms per meter cubed, times 9.8 times H is how high the mercury is going to go up the tube. And we find out it's 0.76 meters. Let's convert that to millimeters. 760 millimeters of mercury. And millimeters of mercury is a unit of pressure. And this is the concept behind Torricelli's barometer, that you can measure the air pressure by the height of fluid that rises up in a vacuum tube. So 760 millimeters of mercury is an accepted unit of pressure, but we also call millimeters of mercury a torr, T-O-R-R, in honor of Evangelista Torricelli. So what if we replaced the mercury with water? Let's run through this example. So we again have air pressure pushing down on the water, 101,325, and that air pressure is going to push water up that vacuum tube. So the question is, how high is the water going to go up the tube compared to the mercury? So we can run through the calculation where we have pressure equals rho GH. We still have air pressure pushing down 101,325. The density of water is 1,000 times 9.8, and we can calculate H. And we find out that water will go up this vacuum tube 10.3 meters. That is way higher than 760 millimeters of mercury. So we can see why Torricelli made his early barometer with a fluid like mercury. We wouldn't want our measuring instrument to have to be 10.3 meters tall. So that worked well to use mercury. So water, however, will go up 10.3 meters. And that's why many towns have water towers that are 10.3 meters tall. They don't have to pump or push the water up into the storage reservoir. Air pressure alone will push that water up 10.3 meters. And if you saw a water tower that was taller than 10.3 meters, we just know there has to be a pump involved in the system somewhere. I hope you enjoyed the lesson.